Assalamualaikum warahmatullahi wabarakatuh and a very good day, Dr. Azhar and my fellow classmates. My name is Nur Syafiqah binti Saipul and my metric number is 141797. We are from Group 8 and here is our group members. Firstly, I will introduce about magnetic particle inspection. Magnetic particle inspection is used to detect both production discontinuities such as seams, laps, grinding cracks and quenching cracks, and in service damage such as fatigue and overload cracks. Besides, castings, foggings, and weldments are among of the product that can be inspected using this procedure. Magnetic particle inspection is used in a variety of industries, including structural steel, automotive, petrochemical, power generation, and aerospace. Next, I will talk about the magnetism. Magnetism is known as the ability to attract other matter to itself. Magnetic or magnetized things are those that have the property of magnetism, and magnetic lines of force can be found in and around them. The point where a magnetic line of force exits or enters a material is known as a magnetic pole. Here are the characterization of magnetic field lines. It forms complete loops. The magnetic field lines do not cross. The magnetic field lines also follow the path of least resistance. It have the same strength. It is also have a direction such that they cause poles to attract or repel. How does the magnetic particle inspection work? A ferromagnetic test specimen is magnetized with a strong magnetic field created by a magnet or special equipment. If the specimen has a discontinuity, the discontinuity will interrupt the magnetic field flowing through the specimen and a leakage field will occur. Finely milled iron particle coat with a dye pigment are applied to the test specimen. These particles are attracted to leakage field and will cluster to form an indication directly over the discontinuity. This indication can be visually detected under proper lighting conditions.
Hello Doctor, I am Ahmad Shahir bin Abbas with matrix number 143366 and I am from Group 8. Now I am going to talk about the basic procedure. The basic steps involved are component pre-cleaning, second, introduction of magnetic field, third, application of magnetic media, and lastly, interpretation of magnetic particle indications. When inspecting a test part with the magnetic particle method, it is essential for the particles to have an unimpeded path for migration to both strong and weak leakage fields alike. The part's surface should be clean and dry before inspections. Contaminants such as oil, grease, or scale may not only prevent particles from being attracted to leakage fields, they may also interfere with interpretation of indications. Now I'm going to talk about the introduction of the magnetic field. The required magnetic field can be introduced into a component in a number of different ways. Firstly, by using a permanent magnet or an electromagnet that contacts the test piece. Secondly, flowing an electrical current through the specimen. And lastly, flowing an electrical current through a coil of wire around the part or through a central conductor running near the part. Two general types of magnetic fields, which are longitudinal and circular, may be established within the specimen. The type of magnetic field established is determined by the method used to magnetize the specimen. A longitudinal magnetic field has magnetic lines of force that run parallel to the long axis of the part, while a circular magnetic field has magnetic lines of force that run circumferentially around the perimeter of a part. Being able to magnetize the part in two directions is important because the best detection of defects occurs when the lines of magnetic force are established at the right angles to the longest dimension of the defect. This orientation creates the largest disruption of the magnetic field within the part and the greatest flux leakage at the surface of the part. An orientation of 45 to 90 degrees between the magnetic field and the defect is necessary to form an indication. Each part is normally magnetized in two directions at right angles to each other, since defects may occur in various and unknown directions.
I'm Muhammad Khadi. Okay. Producing a longitudinal magnetic field using two methods. First method is core and the second one is electromagnetic magnet. In the core, the component is frequency placed toward the inner or annulus of core to create a longitudinal magnetic field. This results in magnetic line of force parallel to the test part along axis, as you can see in the image. Where the second method is electromagnetic magnet is to create a longitudinal magnetic field, permanent and magnet and electromagnetic will be used. The magnetic line of force flow from one pole to another, and the poles are arranged in such a way that any force run normal to this line of force. Circular magnetic field. Circular magnetic field are produced by passing current to the part or by placing the part in a small circular magnetic field. Several techniques of injection current in a component to create a circular magnetic field included a headshot on a wet horizontal test unit and the use of wand. Another technique to create the field is to place the component on the center conductor carrying a high current. Application of magnetic media. Dry particle or particles submerged in a liquid can both be used in MPI. Dry magnetic particle. The particle are lightly dust on the surface. The dry method is more favorable than the liquid method. Magnetic particle cut in a various of color. It can use a color that stands out against the background. For example here, wet magnetic particle. The part is flowed with a solution carry the particle. The wet method is usually more sensitive since the liquid carry allow the magnetic particle to move much more quickly. Wet particles are typically supplied as a visible or fluorescent skin. Particles that are visible are observed in a regular white light, whereas fluorescent particles are observable in a dark environment, as you can see in the picture. Interpretation of indication. After applying the magnetic field, indication that form must be interpreted. The inspector must discriminate between relevant and not relevant signal during this process. The photo below shows important indication product by the magnetic particle abuse on range of component. First, as we can see, the lead of fuse in red, as you see. Second is the spin spice with a service indicator crest, and the third one is we use a wet particle method, and the last one we use dry powder method.
My name is Muhammad Faris Saika bin Nurul Effendi. My matrix number is 144155. Today I would like to talk about demagnetization of magnetic particle. So what is demagnetization? Demagnetization is the act of rescrambling this fully magnetized domain so that the net effect as viewed from outside the object is that there is no external field. But inside the material, this domain remains fully magnetized. After conducting a magnetic particle inspection, It is usually necessary to demagnetize the component. Magnetic fields can affect machining by causing cuttings to cling to a component, interfere with electronic equipment such as compass, create a condition known as arc blow in the welding process. Arc blow may cause the weld arc to wander or feel metal to be repelled from the weld, cause abrasive particles to cling to bearing or fairing surface and increase wear. Parts inspect by using by the magnetic particle approach may have an unwanted residual magnetic field that interferes with later manufacturing process or component service. Required for demagnetization are required for aircraft parts, rotating parts, and components to be welded, machined, or electroplate. There are various methods of demagnetization such aperture type coil reversing step DC, aperture type coil reducing AC, AC or reversing DC aperture type coil withdraw component along the coil axis, act electromagnet heating to above the Curie point, about 770 degrees Celsius for steel. Advantages of magnetic particles inspection. The first one is high sensitivity. High sensitivity is small discontinuities that can be detected. It is quick and relatively uncomplicated. Second, gives immediate indication of defect. Indications are produced directly on the surface of the part and constitute a visual representation of the flaw. It gives immediate indication of defects. The third is minimal surface preparation. There is no need for paint removal. It shows surface and near surface defects, and these are the most serious ones as they concentrate stresses. The fourth is portable. Portable is small portable equipment and materials available in spray cans. Last is inexpensive. It is inexpensive compared to radiography. Disadvantages of magnetic particle inspection. Most methods need a supply of electricity. It is restricted to ferromagnetic materials and usually use iron and steel, and cannot be used on austenitic stainless steel. The method cannot be used if a thick paint coating is present. It can get messy because chemical handling and proper disposal are required. Some of the paints and particle suspension fluids can give a fume or fire problem, particularly in a confined space. First, the inspection method can be quite time consuming depending on the quantity, configuration, and other features of the part or component to be inspected. One reason for this is the need for inspecting in two 90-degree opposing the directions. This is to ensure discontinuities are detected regardless of the component's orientation. Some of personnel still forget this and take the shortcut, which result in inaccurate detection. Another limitation of the method is that the material to be inspected should be ferromagnetic. This disqualifies some metals such as magnesium, aluminum, and stainless steel. As a result, it is crucial to know the constituting material of the alloy or part to be inspected. After all, this NDT method heavily relies on magnetism and the flow of current. Errors can be made regarding the detection results if we are not sure about the constituting materials of the object we inspected. The demagnetization is another issue because we had to run a magnetic current through the component in the first place. This can be sometimes difficult and time consuming. For example, demagnetizing long bars may require changing the direction of the bars with respect to the demagnetizer and the Earth's magnetic field.